The universe will not die in a single explosion. Its death will happen one light at a time. First, distant galaxies will disappear. Then the final stars will fade into darkness. Matter itself may begin to fall apart. And after an almost unimaginable amount of time, even the largest black holes will be gone. But that still may not be the end. Because the final light in the universe could appear at a time so distant that even a Google years would seem like nothing. This is the complete timeline of the universe's death. Before we begin, there is one important warning. We do not know the true nature of dark energy, so nobody can predict the future with absolute certainty. This timeline follows the leading scenario in which the expansion of the universe continues forever. And if that scenario is correct, the universe has already begun its slow journey toward darkness. The age of starlight. The universe is currently about 13.8 billion years old. It contains hundreds of billions of galaxies, enormous clouds of gas, and more stars than anyone could ever count. But this bright period is only a tiny part of the universe's potential lifetime. We are living in what scientists call the stelliferous era, the age of stars. New stars are still being born, but the universe has already passed the peak of star formation. Galaxies are slowly using up their remaining supplies of cold gas, and fewer stars are being created with each passing billion years. The night sky may look permanent to us, but the universe is already running out of fuel. 100 billion years from now. As the universe expands, the distances between gravitationally unbound galaxies continue to grow. The expansion is accelerating, driven by whatever dark energy truly is. Eventually, distant galaxies will move beyond our cosmic horizon. Their final light will become increasingly stretched, red and faint until it can no longer reach our region of space. In roughly 100 billion years, almost every galaxy outside our gravitationally bound local group will have disappeared from view. They will not be destroyed. They will simply become unreachable and invisible. Any astronomers living in this distant era could look into space and see only one enormous galaxy, the final product of the galaxies in our local group merging together. The wider universe would still exist, but there might be no visible evidence of it. For the first time, the observable universe would begin to feel truly empty. The final generation of stars. Over the following trillions of years, galaxies will continue using their remaining gas. The largest stars will disappear quickly. Smaller stars will survive much longer, and the smallest red dwarfs will become the final normal stars in existence. Red dwarfs consume their hydrogen incredibly slowly. Some may continue shining for trillions of years, hundreds of times longer than the universe has existed so far. But their fuel is not infinite. New stars may occasionally form when failed stars collide or when surviving clouds of gas collapse. These events will become progressively rarer until the universe can no longer produce stars at all. By approximately 100 trillion years from now, the age of normal star formation will be over. Somewhere in the darkness, the last red dwarf will consume the final hydrogen inside its core. It will not explode dramatically. It will slowly grow dimmer until its light disappears. The age of starlight will end quietly. The degenerate era. The universe will now be filled with the remains of dead stars. White dwarfs will slowly cool until they become black dwarfs, dark, frozen objects that currently do not exist because the universe is not yet old enough to create one. Neutron stars will continue spinning in the darkness. Failed stars, dead planets, and other remnants will orbit the remains of ancient galaxies. But even these structures will not survive unchanged forever. Over periods approaching 10 to the power of 20 years, repeated gravitational encounters will disrupt the orbits of surviving objects. Some will collide. Some will fall into black holes. But many will be launched out of their galaxies and into the expanding darkness. The galaxies themselves will gradually dissolve. Every surviving object will become an isolated island, separated from everything else by distances that continue growing forever. Will matter itself disappear? What happens next depends on one of the greatest unanswered questions in physics. Are protons stable? Protons are fundamental components of ordinary matter. Every planet, dead star, and human body contains them. Scientists have never observed a proton decaying, but some theories suggest that it could happen after an extraordinarily long time. If protons can decay, ordinary matter will eventually begin to dissolve. Dead planets, neutron stars, and frozen stellar remnants will slowly break down into lighter particles and radiation. Objects that survived for countless trillions of years will disappear atom by atom. Eventually, almost every remaining concentration of matter will be gone. Only black holes will continue to dominate the darkness. The black hole era. Black holes may appear eternal, but according to quantum physics, even they can lose energy. Through a process known as Hawking radiation, black holes are expected to release an almost undetectable amount of energy and gradually lose mass. For most of their existence, this process will be unbelievably slow. A stellar mass black hole could survive for roughly 10 to the power of 67 years. The largest supermassive black holes may remain for around 10 to the power of 100 years. That is a googol years, a 1 followed by 100 zeros. For comparison, the current age of the universe contains only 10 digits when written in years. During the black hole era, the universe will be almost completely dark. For vast intervals of time, nothing noticeable will happen. Then one by one the black holes will evaporate. As a black hole loses mass, its temperature rises and its evaporation becomes faster. In the standard description, its final moments may release a brief burst of particles and radiation. Eventually, the final supermassive black hole will disappear. But depending on the stability of matter, this may still not be the universe's final flash. The last supernovas. If protons never decay, some black dwarfs could survive far longer than the black holes. Although these frozen objects would be almost completely inactive, quantum tunneling could allow nuclear reactions to continue inside them at an impossibly slow rate. Over time, their lighter elements could gradually be transformed into iron. As the amount of iron increases, the structure supporting the black dwarf could weaken. Eventually, some of the most massive black dwarfs may collapse and explode. The first of these hypothetical black dwarf supernovas might occur after 10 to the power of 1,100 years. The final ones could take place around 10 to the power of 32,000 years into the future. The numbers are so enormous that writing out their zeros would take longer than this entire video. By then, every surviving black dwarf would be isolated beyond the cosmic horizon of every other object. Each explosion would illuminate its own tiny region of space, with nobody and nothing close enough to witness it. These could be the final stars to produce light. After the last explosion fades, the universe will enter its final era. Heat death. Heat death does not mean that the universe will suddenly switch off at a particular moment. The universe may continue expanding forever. Its temperature may move closer and closer to absolute zero without ever fully reaching it. But there will no longer be concentrated sources of energy. No stars. No galaxies. No planets. Perhaps no atoms and no black holes. Only incredibly low-energy particles and radiation, separated by an ever-growing expanse of almost perfect emptiness. Without differences in energy, no complex process can occur. Nothing can burn, shine, grow or power any meaningful change. Time may continue, but there will be almost nothing left capable of measuring it. The universe will not have been destroyed. Space itself will remain. But everything that once made the universe active, bright and complex will be gone. The universe began in an incredibly hot and dense state filled with energy and possibility. Its final state may be the exact opposite: cold, empty and almost perfectly still. Not an explosion. Not a final moment. Just an eternity in which nothing new can ever happen again. Thanks for watching and I'll see you next time.